Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 12 in our incredible new tutorial series where you're learning how to do 3D graphics and animations in Python. What I'm going to need you to do is pour yourself a nice strong cup of black coffee. That is straight up black coffee, no sugar, no sweeteners, none needed. That's your goat juice. Go get you some. What I am also going to need you to do is I am going to need you to fire up your most excellent Visual Studio Code. And as you're doing that, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough this shameless self-promotion. Let's jump in and talk about what we are going to learn today. And what we are going to learn is we are going to begin to learn about orienting objects in three-dimensional space. Now, what do we know how to do right now? We can create an object and then we can move it in X, we can move it in Y, or we can move it in Z, or we could change its size. We could also change its color and change its opacity. Those are the things we've learned so far. But you're not always going to have your items be lined up with the coordinate axis. So it's not always going to be pointing along the x-axis. What if you wanted it up here at an angle, or to orient it more arbitrarily in three-dimensional space? And that's what we're going to begin to undertake today, is to teach you how to do that. And we do that with the Visual Python axis parameter, and I will be showing you how that works today. So let me go ahead and get out of your way, and we will come over here. We are working in the most excellent Vpython. We are working in the most excellent Vpython folder. We will create a new program called, let's just call it axis, A-X-I-S dot axis orient, like that, axis orient dot py. No dot, I said dot wrong. It's axis orient dot py. Okay, the dot .py is kind of important. We will hit that, and boom, we have a fresh new Python program just waiting for you to write it. We will start by importing who? Importing our friend Mr. Vpython. So from Vpython import star, like that. And who else is your friend? Mr. NumPy is your friend. So we are going to import NumPy as NP. Make sure that it doesn't autofill that for you. It's hard to get it to not do that. NP, and it keeps doing that. This is annoying me. Okay, let's see. All right, so now we have Vpython and we have NumPy. All right, now what we want to do is we want to just think of, we're going to make an arrow, right? Because an arrow points, and therefore it's easier to understand orientations if we use an arrow. So what I'm going to do is I'm going to create my X arrow, and my X arrow is just going to be, let's give it a color, color equal color dot red. And then I want to do a little better with doing parameter design, and so stop that. Up here I'm going to set a parameter of arrow length, and I'm going to set that equal to 2. So I'm going to be doing parametric design. Also, I want a shaft width, and so my arrow thickness is going to be the shaft width, like how thick the shaft is, and I'll make that like a 0.1, I think. And so that arrow T is going to be the thickness of the arrow. And then I will come down here and I will put those in and say my length is going to be equal to arrow L. I will move that where you can see it. I'll get this out of your way. My length is equal to arrow L, and then my shaft width, make sure you spell that right, shaft width is going to be equal to arrow thickness. All right, now you guys remember that when you're creating a graphic, you got to keep the program alive, so I'll just say while true when it's true, true, true is always true. What do I want to do? Pass. So this is just going to loop forever, so it keeps the graphic alive. So this should create an arrow, all right, of length 2 and shaft width of 0.1. Let's see how this looks. Whoa. What did I do? Oh, that was crazy, wasn't it? It's X arrow is my object, and that is equal to arrow. Arrow is the Vpython command that creates an arrow. All right, we'll get this rolling here. Okay, boom, got an arrow, and you can see the default position is it is pointing in the X direction. It is pointing in the positive X direction. It is kind of kludgy. It is too big and fat. I think I want to make that quite a bit smaller, so I'm going to say 0.01. Let's see what that looks like. Get something that looks like a decent arrow. All right, boom, I think that's pretty good. It's an arrow, its length is 2. It's a little bit too thin, so me and my OCD, in my mind there is a perfect arrow, and we want to get that perfect arrow, and so here we go. And that, my friend, is the perfect arrow that I wanted to get. So the thing to notice is that it points it in the positive X direction. That is where it points it. And you can point it in other places by, when you create it, make the axis parameter. And the axis is a vector, so it is equal to a vector, and you give it 3 parameters, where it's pointing in X, okay, where it's pointing in Y, and where it's pointing in Z. Well, if we want it to just point in X and not in Y and not in Z, that would be saying let's come out 1 in X, go 0 in Y, and go 0 in Z, and it should point it right there. So I'm going to say go in the X direction, not in the Y direction, not in the Z direction. And now that should be exactly what we had before, because I think that is the default. So let's just make sure. Boom, exactly the same. All right. Now you guys tell me, if we wanted it to point up instead of over, what would this be? Well, if this is X and this is Y and this is Z, we would make this 0, we would make this 1, and then Z would be 0. And so if we do that, boom, it's pointing up, all right? What if we want it pointing at us in the Z direction? We would make it 0, 0, and 1, like that. Okay, and you see that's coming out the page at us in a kind of awkward way. All right, so you see that's coming out the page at us. All right, so you begin to see how this axis command allows us to know where to point. And so let's play around a little bit more with it. So I'm going to get my X arrow. I'm going to change it back to X. So it's going to be 1, 0, 0. And then let's snag that line of code, because we don't want to type the whole thing in again. And then we're going to come down here. And what is this one going to be? Let's make this our Y arrow, and our Y arrow is going to go in 0, turn on the Y to 1, and then 0 in the Z. And then let's make this color, let's make this green, G-R-E-E-N. I'm trying to create a coordinate axis with red and then green, and then out towards me is going to be blue. Okay, so that is going to be like that, and then I can do that. And let's see what happens. We should have an X and a Y now. Boom, we got a coordinate axis, an X and a Y. Looking good. I really like that. Okay, I want to show you another thing that you could do. You could come here and you could do another one and make that Z. And so this one is going to be blue. So we're going to have red, green, blue, and we're going to have a 3-dimensional axis. Now we're going to create red, green, blue, and then we're going to have a 3-dimensional axis. And this one is going to be 0 and 0 and 1. Okay? And so that we're going to kill the old one and we're going to run it, and I should have a good 3-dimensional axis. Boom, look at that. Okay, perfect. Do you see we have a three-dimensional axis? All right, now there's one quirky thing. There is one quirky thing about this that you've got to know. And that is, let's say that I didn't give it an axis here. Okay, let's say I created it, and I still created it with that length of arrow length, which is 2, right? But let's say that I create it, and then I come down here. I come down here to set its axis. So basically I'm changing the axes. So now what I'm going to say is, whoa, and this was supposed to be Z arrow. I'm sorry. The reason it worked because it just created a new one, all right? But now what I'm going to do is I'm going to say Z arrow dot what? What am I going to change? Its axis, because I want it to point in the right direction, so that's going to be a vector. And then what direction do I want it to point in? Well, I want it to point in the Z direction, which is 0, 0, 1. And this is kind of exactly what we did before. The only difference being is I'm creating it in the default position, which is X, and then I'm changing it to the Z direction. So let's see what happens when we do that. Okay, and this is going to show you the problem. What is the problem? If you change the axis statement, it changes its size. When you change its axis, it changes its length. And I want you to see what it did, okay? When you set length to what up here? You set length to 2, and it was 2. But then when you change the axis, it changed its size. And when it said 0, 0, 1, it's thinking, well, I guess he wants it to be 1 long because he's saying go out 1. And you could think, oh, we'll go out 0, 0, 2, and that would fix it. No, then you're not doing parameter design. So this is the way you do it. You set the axis, and after you set the axis, you immediately fix the length. Okay, and that is back to arrow length like that. And I think that should fix it. But you've always got to be mindful. Anytime you change where something is pointing, you have to go back and tell it what size it's supposed to be again. And that didn't fix it. That did not fix it. Why did that not fix it? I think I must have had a error in there. Oh yeah, typo. Did you guys see that? Let's try it now. That one scared me. It kind of scares me when it doesn't. Boom. Okay, do you see that? Everything's the right size now. So learn this lesson. Anytime you change where something is pointing, after you change where it's pointing, go back and remind it what its size is, or you're going to have all kinds of difficulty. Okay, so let's go back and let's do this the way we should do it. And so we're going to take this and copy it, and then we're going to set this up as axis is equal to vector like that. So we get that back in there, and we will take out this little experiment that we did. Now, why are we okay here? Because we set the axis, and then out here we set the length, and so it points it, and then it sets the direction up. So that works. Okay, now that is really easy if you're pointing in the X direction, the Y direction, and the Z direction. But what if you want to point somewhere else? I'm just going to tell you, you guys, it will not work. Like, let's say if you wanted a 45-degree angle and you said, well, let me set X to 1 and Y to 1. You're never going to make it do what you want by trying to do things that way. You have to think in terms of how long is your vector, its arrow length, and then what angle do you want to point it at. So like this is an angle of 0, and that's an angle of 90. 0, 90, 90. That would be 45 degrees. So you've got to think in terms of pointing it. And therefore, you've got to learn a little trigonometry. Guys, I'm going to teach you the trigonometry. And if you will pay attention, you will understand it. Don't get afraid. I'll show you how to do it. But you've got to learn the trigonometry if you're going to be able to animate things and make them do what you want them to do. You've got to understand some very simple trigonometry. Better take an extra shot of coffee here. Okay, The first thing in trigonometry that you are going to have to learn is you are probably familiar with degrees, measuring things in degrees. And when you measure things in degrees, how many degrees in a circle? There are 360 degrees if you go all the way around. So this is like 0, 90, 180, 270, and then 360. So if you go through 360 degrees, you get all the way around, right? This is the problem. The world of engineering does not operate in degrees, and the world of Vpython does not operate in degrees. It operates in radians. How far is it all the way around the circle in radians? It's 2 pi radians. So if you go all the way around, you've gone 2 pi. So this over here that was 180, that is half of all the way around, that is pi. So what is this? This is pi over 2. So you could view it as 0, 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, and then 4 pi over 2. 4 pi over 2 is 2 pi. So you see, go all the way around, you go 2 pi, and each 90 degrees you can think of as pi over 2, another pi over 2. Does that make sense? So let's try to draw that up here just to make sure that you can see that. And so we're going to draw a little bit of a coordinate axis here. I think you can see that. Okay. And so then you have this vector that you are spinning around. Okay, this vector is spinning around. And if it goes this far, it has gone pi over 2 radians. If it goes this far, it has gone pi radians. If it has gone this far, it has gone 3 pi over 2 radians. And then all the way around is 2 pi. And so you go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. 4 pi over 2 is 2 pi. 2 pi over 2 reduces to pi. So you count by pi's over 2. Now if you see this at 45 degrees, what would that be? Well, that would be halfway to 90, halfway to pi over 2 would be pi over 4. And if you want to go from degrees to radians with a formula, what you can say is radians. How many radians do you have? Well, it's equal to degrees, how many degrees you're in, and you divide degrees by 360, and then you multiply by 2 pi. Okay, so this will take degrees and convert it to radians if you ever need to do that. Okay, now what we want to do is we want to think about, we can do this case, 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 but how about the cases in between? Well, what you got to see is that this vector, as it spins around, its length doesn't change. It's that arrow length. The length doesn't change. Well, here clearly I go over 1 and I go up 0. I go over 1 and I go up 0. So for that case, what I'm saying is I go over 1 and I go up 0. Didn't mean to move that. I go over 1 and I go up 0. Or in this case, I go over 0 and I go up 1. Those cases are really clear, but how about the in-between cases? What I still need is I need the how far over in X and how far up in Y, which is just exactly what I did before. Over 1, up 0. Over 0, up 1. It's how far over and how far up. Well, for right here, you're still going to go over by some X amount, and you're still going to go up by some Y amount. Or I'm going to go way over in X and up just a little bit in Y. So it's still, think of this tip of this pen as having an X value and a Y value, okay? But what are those X values and those Y values? Well, you get them using trigonometry, okay? So I will draw another axis here, and if you're not seeing it, don't worry. Once I've drawn it, I will show it to you. Okay, that's pretty good. You can see that. And so then we're going to have this vector that is how long? Well, it is arrow length, but we're just going to call it L here. And so this vector is L long, and then you have to think that you are going through some angle. And then you've got the tip of the vector here, right? The tip of the vector is at some x value, and it is at some y value. Okay, so remember, you're going to go over some x, you're going to go over some x, just like before, but it's not going to be the 2 or the 1 now. You're going to go over some x, and then you're going to go up some y. Over some x and up some y. And then you end up where? You end up at the point, what? X, y. Well, you can see if you have a little bitty angle, you're going to be way over an x and up just a little bit. Or if you have an angle that's getting close to pi over 2, you're going to go over just a little bit. X is going to be small and y is going to be large. But there's a formula that allows you to calculate it as a function of what that angle is. And what it is that this x value, how far is it from here to here, depends on the angle. And that x value is equal to the length of the vector L times the cosine of the angle. All right. If you've never heard of cosine before, if you've got a scientific calculator, it's got the cosine button on it, or you can go to a website and you can look up the cosine of an angle, or in Vpython, since we're using NumPy will calculate the cosine of an angle. So how far over are you? Well, you take L and you multiply it by the cosine of the angle. And then similarly with y is equal to the length of the vector times the sine of the angle. And that angle symbol is called theta. Okay, theta, T-H-E-T-A. So if I want to put in pi over 4 here, then I can use these two things to calculate the x and the y that will put my vector point right exactly there. And so what is that point? Well, that point is L cosine theta, comma, L sine theta. And that will put me, that L cosine theta, comma, L sine theta, that will put me, boom, right at that point. Don't believe me? Let's give it a try. So we will come back over here, and let's add another parameter, and let's call it theta. And what is theta? Well, we want theta to be pi divided by 4, right? Because that is pi over 2, 45 degrees would be pi over 4. But now how do we get pi? There is a function that will give you pi. You could type in 3.141592654, or you could just do np.pi. And np.pi will return to you 3.14. So anytime you need the variable pi, you just put in np.pi and make sure that you have imported the numpy function. Does that make sense? Okay, so now I have a theta. Now I'm going to create a pointer arrow, and that is going to be equal to the arrow. And then I need to set up the axis. Now the axis is going to be equal to the vector. All right, but the x value is not going to be 1 because I want it at that pi over 4 position. So what would the x value be? What would the x value of that point be? What would the x value of that point be? L cosine theta. So we will come over here and we will put in arrow length, right? Arrow length was our L, times, how do I get cosine? Well, it is a numpy function, so it's np.cosine. And what's your angle? Theta, right? I set the theta up over here. So that's my x value. Oh, you haven't seen that. Let me come back over here. Sorry about that. Okay, so I'm going to create an arrow, PNT arrow. It is going to equal arrow, and then I'm going to set the axis. Okay, the vector is going to be arrow length times np dot cosine theta, and then that's the x value. Then what is the y value? What is the y value? The y value is L sine theta, right? So we'll come back over here, not forget to do that, and say that is going to be arrow L times np dot sine of theta. Okay, and so that closes my sine function, and then that closes my vector, and then that closes the whole arrow thing. So after my axis, now I'm going to come on in, I'm going to say color is equal to color dot orange, and then length, I'm doing that after I point it, so the length will be right, is equal to arrow length, and then shaft width is equal to arrow thickness, like that. Now what should this do if I haven't made a mistake? It should point it at the pi over 4. It should point it at the pi over 4, and then it should make it too long. And the reason it's going to make it too long is I set the length after I gave it the vector command. So x value is L cosine theta, y value is L sine theta. Coming back over here, x value is, this is our length, np cosine theta. This is our length times np sine theta. That is for y. And what did I forget? I forgot to put in a value for z, so I got to put in comma 0. And why do I put in 0? I'm spinning this way. I'm not spinning this way. So z is always going to be 0 because I'm rotating in the xy plane. Let's just give this a shot and see what happens. Boom! Do you see that? 45 degrees. Look at that. We got it right there at pi over 4. Boom. So what if we wanted it half again, which would be half of 45 degrees, which would be 22.5 degrees? Well, we would, instead of pi over 4, we would make it pi over, instead of pi over 4, we would make it pi over 8, right? And so let's try that, and that should be halfway to 45 degrees. Boom. And do you see, as that thing is moving around, it is always the right length? What if we made it like pi over 24, and that would just be barely up a little bit? And let's watch that, okay? Boom. Okay. Now, what, you guys tell me, if I just made this np dot pi over 2, where would that put it? Can you think through that? Let's try. Let's kill this. Come up here. Okay. Put it straight up, right? Pi over 2 is straight up. So, man, this is working perfectly. Okay, this is working just like we expected it. And we're doing good. We're doing good to use parameterized models. Okay, now what do we want to do? We want to animate this where that point arrow is actually rotating around in the XY plane. Rotating around in the XY plane. How would we do that? Pause for a second and kind of think how you would do it, and then I'll kind of show you how I'm going to do it. Okay, we're going to come over here and we're going to create this, but we're going to start it at 0, right? So instead of starting it somewhere, we're just going to start it at 0. Stop that. That's really annoying there. Okay, So we're going to start it at 0. It's still going to be too long. We're going to start it, and now we want it to just sit and rotate. Well, what would we do? Inside this while loop, we're going to need a what? We're going to need a for statement. And I'm going to say for, I'm just going to say my angle in what? Who's your friend? np dot lens space, because that's the easiest way to create a for loop. Where do we want to start? We want to start at an angle of what? 0. Okay. Now, if we're going to spin all the way around, it's going to go to what? All the way to 2 pi. So how do I do that? 2 times np dot pi. And then how many steps do I want to go? Well, we want it to go really smooth, so let's make it go 1,000 steps, and that way it's not jumping, right? It'll be really smooth. So let's go 1,000 like that. All right. Now we get rid of this pass nonsense. Okay. Now what do we want to do? Well, what am I changing to get this thing to spin? I'm changing the axes. I am changing the axis of what? My point arrow dot, what do I want to change? Its axes, and that's going to be equal to, the axis is always a vector, and what is the x value? What is the x value? L cosine of theta, right? L cosine of theta. So that is going to be arrow length with the uppercase L, like that, arrow length times np dot cosine, not of theta, but the angle I'm stepping through is what? This is my index, my angle, right? If you set it to theta, theta is not changing. Angle, all right. Then, so arrow length times np cosine of my angle. Got to be real careful with your commas. Now I've got to do the y value. Well, that's arrow length times np dot what? Who's your friend? Sine this time for the y. And that's going to be my angle. And then still I've got to do the z. So the third parameter z is always going to be 0. Right, and that's the only thing that I'm changing is point arrow dot axis. Now, from what we learned earlier, though, when I change the pointing, it's going to resize it to the wrong thing. So immediately I need to fix that and say point arrow dot length is equal to arrow length, just to fix the pointing messing up the length problem. All right, now let's see here. We might need to go ahead and put a rate in here just because we are doing a Vpython in a loop, and a lot of times it wants to see a rate. So let's just put 50. I'm just guessing that might be way too fast or way too slow. So let's see what happens here. Give that thing a try. Shazam! Do you see that? Pi over 2. Coming up around the corner to pi, going to 3 pi over 2, all the way back to 2 pi. What's it going to do at 2 pi? Now in the while loop, it goes back and it's starting again. It's starting that for loop again. So you see how we have animated that thing? Boom! Look at that. And you learned a little trigonometry and you learned about radians today. Okay, guys, when you're doing orientations, anything besides the very simplest of here or here or here or here, you have to do your sines and your cosines. Okay, you have to do your sines and cosines. And I've shown you how to do that. I've shown you that you have some angle, and your x value is the length of your vector times the cosine of the angle. The length of your vector times the cosine of the angle. How high do you go? That y value is L times sine of theta. And then when you do that, you get this work of art here, this beautiful vector And do you see how it's just going right in that XY plane? It's not out in Z at all. And so that is just absolutely amazing. You know, I'm always kind of picky. What I think I'm going to do is I would like to make, I'm going to make that one a little thicker. So where I have arrow thickness, I'm going to also make a PNT thickness, and I'm going to make that like twice as much, like 0.04, just so it stands out a little bit more. And then here where I create it, I would want to make it point thickness. Right there where I created it, PNT thickness like that. And that is where I created the point arrow. All right, let's try that. It should be a little thicker and easier to see this time. Look at that. I like that. I really like that. Okay, guys, this is your homework assignment. I want you to write a program that does what I just did, but you're going to go around the XY axis. When you get to here, you're going to go around the XZ axis like that. Okay, and then you're going to go around the YZ, right? So what am I going around right now in this illustration? I'm going to go from X. Now watch me. I'm going to go from X to Y. So I'm rotating in the XY plane. After I make one full circle, I want to start at X and go to Z and rotate in the XZ plane. And then when I come back, I want to rotate in the ZY plane. Okay, so you see you're going to take a trip around. You're going to take a trip around going from the XY plane. Then you're going to make a trip around in the XZ plane. And then you're going to make a trip around in the YZ plane. That would be starting at green and going to blue like that. I've given you everything that you need in order to do that. I really have. I've given you everything that you need in order to do that. And so I want you to make 3 trips around, transversing each one of the coordinate axis sets. Okay, guys, this is really kind of fun. I hope you guys are enjoying this. We're going to have some fun in the next lesson. Really try to do it. You should be able to figure it out with what I've shown you. You really should. And it's very symmetric. It's just you're going to kind of be, you know, the point arrow, you're going to kind of be playing around with where this is, and you're going to be playing around with where this is. But I think if you play around with it, you'll be able to figure it out. Okay, guys, I am having a lot of fun with this. I love Visual Python. I hope you guys are having fun. Be sure, if you enjoyed the video, to give me a thumbs up. Also, if you haven't already subscribed to the channel, when you subscribe, make sure you ring that bell so you'll get notifications when my next videos are coming out. And then share this with other people, right? Because the world needs more coders and fewer people sitting around watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.